Okay, for problem 4, before we actually dive into the meat of problem 4, I want to give you a little bit of background for empirical formula and molecular formula. So if you have a compound, so what's the one you're most used to? Something like water. Okay, so the molecular formula for water is H2O, and it ends up, for reasons that'll be clear in a second, that the empirical formula is also H2O. The molecular formula tells you exactly what is in the molecule. The empirical formula tells you the ratio of the elements. So there's 2 hydrogens to 1 oxygen. But if we had something like even a simple molecule like this, okay, this molecule, I would simply count the hydrogens, count the carbons, and its molecular formula is C2H6. However, its empirical formula is CH3. Okay, and it's because of this consequence of, if you think about it in terms of fractions, something like 2 over 6 is equal to 1 over 3. And the experiment that we do to get the empirical formula only tells us the ratio of the elements. So it tells me that there's 1 carbon for every 3 hydrogens. That's still true up here. For 2 hydrogens, there's 6 carbons, so the ratio holds, but they're different. So the molecular formula can be the same as the empirical formula, or it can be different. It's going to be different anytime we can do something like this, where we divided, in this case you could think about dividing both of those coefficients by 2. 2 by 2 divided by 2 gives me a 1, and we don't show 1s. And then a 6 divided by 2 gives me 3. So you can think about this as like simplifying a fraction down. So now I'll walk you guys through how you can figure out what the molecular formula is with some additional data. And so for this problem, you're given the empirical formula and you're given the mass of the molecule. And it is always true that the mass of the molecule is equal to some integer x, so a counting number, 1, 2, 3, 4, 5, times the mass of the empirical formula. The mass of the empirical formula I've worked out is 5 times the mass of carbon, plus 10 times the mass of hydrogen, plus 1 times the mass of oxygen. So the empirical formula mass is 86.13. Now I'm just going to go and fill my data in here. So the mass of the molecule was given, 258.42, and that's equal to x, some integer, times this 86.13, the mass of the empirical formula. So x then is 258.42 divided by 86.13. So it comes out very, very close to 3. And so the molecular formula, for it to be 3 times heavier than the empirical formula, I have to triple all of the elements. So I had 5 carbons, so 5 to 15, 10 to 30, and 1 to 3. So the molecular formula contains the empirical formula unit 3 times.